All right, I've got 3 more examples to look at in this last section. First up, I have the indefinite integral of x times the square root of x plus 1. Now, this one, if I look at it, maybe you say, okay, well, maybe we'll rewrite that radical. I know that those are a little bit difficult for us to manage, so we'll rewrite that as x times x plus 1 to the 1/2 power dx. And a few things that I want to note here. First of all, we cannot take this x and distribute this through because of this exponent of 1/2. So I can't simplify it that way. And if I look at this, I can't split up. Remember, the integral will not play nicely with multiplication. So unfortunately, I can't just say, well, let's integrate x dx times the integral of x plus 1 to the 1/2 dx. This is just not gonna work. So if you look at this, you say, boy, I'm really not sure where to go. Try substitution. If you're ever unsure, if you're looking at a problem and you say, boy, I'm not quite sure what to do with it, substitution is usually your best bet here. So I'm going to take u equal to, and I'm going to pick u equal to x. Let's try that first. U equal to x means du is equal to 1 times dx. That's the derivative of x. So if we try and perform our substitution here, we'll have u times u plus 1 to the 1/2 power du. If you look at what I just wrote and compare it to what we started with, I haven't really accomplished all that much. In fact, I haven't really accomplished anything. All I've done is take out x and replace it with u. I have still the exact same integral. Remember, the whole point of integration by substitution is to make a difficult looking integral and make it easier to work with. This is not easier to work with. So that tells me I've made a wrong choice of u. And this is always going to be the case. You should never, ever, ever just pick x for your u. It has to be something more complicated than that. There has to be more to it than that. So that means, okay, we need to go and we need to try something else. So if it's not x, let's try x plus 1. I guess it's really our only other option. So let's try u equals to x plus 1. Du then will be 1 times dx again. So all right, here's x plus 1. That's my u. Du equals 1 dx. This is my du. I have another problem I need to worry about now. So this x. How do I account for that? Because I don't want to substitute this in. If I try and substitute in everything that I have, I'll end up with x times u to the 1/2 du. I'm mixing and matching my variables again, and I really don't want to do that. So that means I do need to account for this x in some way. So I'm going to look back at what I have here, because this is really all I have to work with. I'm going to look at this guy right here. I'm going to say, hey, can we solve that equation for x? And it turns out that, yes, we can. If I just subtract 1 from each side, that'll give me u minus 1 is equal to x. So I'm actually going to perform 2 substitutions here. I'm going to say this piece right here, this is actually u minus 1. And then this piece that I've highlighted right here, this is u. And then, of course, my dx, that's just du here. So let's look at this after I perform my substitution. This one's going to look a little bit different. But here I'll have the indefinite integral of u minus 1. Be careful with this. I do need parentheses around this guy. Times u to the 1/2 du. You might look at that and say, well, big deal, Mr. H. Like, this doesn't look any easier. And you're partially right. It's not substantially easier, but what this allows me to do now is now I can take this u to the 1/2 and distribute this through, because that u minus 1 does not have an exponent. Well, it has an exponent of 1, but that's not going to stop us from distributing. So we can simplify this a little bit. So let's see, u times u to the 1/2. This is really u to the first power. I'm going to add those powers. So 1 plus 1/2, that would be u to the 3/2 power, minus 1 times u to the 1/2, that's u to the 1/2, du. This is now a lot easier for me to manage because I can just do the power rule here, and I can do the power rule here. So let's do the power rule. I will have u adding 1 to the power. That will give me 5/2. Rather than divide by that fraction, I will multiply by the reciprocal, so I'll multiply by 2/5. Minus over here u adding 1 to the power, that will give me 3/2. Rather than divide by that fraction, I'm going to multiply by the reciprocal. I'll multiply by 2/3. And of course, I have to add in my constant of integration c. But of course, I don't want to leave my answer with u in it. I want to take my x plus 1 and plug that back in. Remember, that was what we originally said u was equal to. So I need to take out u and replace it with x plus 1. So this will be 2/5 times x plus 1 to the 5/2 power minus 2/3 times x plus 1 to the 3/2 power plus c. There is our indefinite integral. So these are a little bit tricky. You actually have 2 substitutions to make. I guess 3 if you want to count du, but this kind of coming up with an extra expression, an extra substitution for u, that is what makes these problems a little bit more difficult than the other examples that we've looked at up until this point. Let's look at another though. So here I have the indefinite integral of x over x plus 2 quantity squared dx. So again, I kind of learned my lesson last time, and I say I don't just want to take x. I don't want to just take that to be my u. Actually, let me just rewrite it here so it's a little bit bigger. X over x plus 2 quantity squared dx. We said we don't want to just take x as our u because that won't actually make my problem any easier. It's not going to solve any of the problems that I have here. So really the only other choice I have is x plus 2. I'm going to take u equal to x plus 2. Du then, derivative of x plus 2, that's going to be 1 times dx for my differential. So I say, okay, here is my u. Here is 1 times dx, that's just du here. I'm left over with this x once again. So I need to look back at this equation that I've written for u and solve it for x. So if I just subtract 2, this is really u minus 2 is equal to x. So when I take out this x, I'm going to replace it with u minus 2. So let's see what this looks like then. So I should have u minus 2 divided by u squared du. Again, this is still not something that I can integrate yet, but at least I can simplify this. I'm going to pull this apart into 2 separate fractions. I'm going to have u over u squared, negative 2 over u squared. So this will be u over u squared minus 2 over u squared du. This term right here I can simplify. I can cancel a u. So let's do that before we integrate. This is 1 over u minus, I'm kind of looking ahead and I say, okay, I know I'm going to want to integrate that. I can't do that with u squared in the denominator. So let's rewrite that as minus 2u to the negative 2 power du. So okay, I can take my antiderivative. I can integrate this. The integral of 1 over u, well, that's just natural log absolute value of u. Minus over there, I am going to have to do my power rule. So let's see, negative 2, actually minus the negatives built in there, sorry, minus 2u to the negative 1 after I add 1 divided by negative 1 plus c. So this is really, let me fix this, minus a negative, that's really plus a positive. I have natural log absolute value of u, but we said u is x plus 2, plus 2 times x plus 2 to the negative 1 power plus c. Or, of course, you could write your answer as natural log absolute value x plus 2 over x plus 2 plus c. Either one of these will be just fine. So that is pretty cool. Be careful with these problems. Just keep an eye out for them. There won't be too many. I think there's only 1 or 2 in the homework exercises, but it is something that you should just keep an eye out for because the procedure is a little bit different. We just have that one extra added step of making an additional substitution for u. Let's look at one last example for this section. Here, I have the indefinite integral of 1 over x natural log of x dx. I like this one. I think it's kind of neat. So I have 1 over x natural log of x dx. Think about your substitution. What are we going to choose here? Remember, I can't split these two apart. I can't say 1 over x and then integrate that, and then 1 over natural log of x. Even if I could, I don't know what the integral of 1 over natural log of x looks like. So I'm going to try substitution because that's really all I have at this point. So remember last time we tried u equals to x, and we saw what happened there. Essentially, if we do that, you'll end up with 1 over u natural log of u du. And the problem doesn't actually get any easier. I just rewrite it with u. So we learned our lesson last time. We're not going to do that again. Maybe I'll try u equals to x natural log of x. Just take the whole denominator. Let's see what happens. U prime, or excuse not u prime, du, excuse me, du. Well, if I want the derivative of this, I would need the product rule. So let's see, derivative of x, that's just 1 times natural log of x plus x times derivative of natural log of x, that's 1 over x. This is natural log of x plus 1. So I say, okay, well, here's my u. And what do I have left over? I've really got 1 dx. And I've got this natural log of x plus 1, and actually I even forgot natural log of x plus 1 dx. I have this extra function of x that really I don't know what to do with. What that tells me is I've made a wrong choice for u. So again, here's an instance where I've intentionally, just to show you guys, I've chosen the wrong u to show you what it looks like if it doesn't work out. Generally, when you choose your u, you should not need to use a derivative rule other than the power rule, derivative of e to the x, or derivative of natural log of x. You shouldn't need to use like a product rule or a quotient rule or a chain rule. Generally, if you have to do that, your u is actually too big. It's too complicated. So we're going to try, let's see. We've tried x, that didn't work. We've tried x natural log of x, that didn't work. Let's just try natural log of x. So if u is natural log of x, du then is 1 over x times dx. And this seems like it's going to work this time because here, natural log of x, this is my u. And here I have 1 over x. I'm going to stretch. And I say, okay, that is my du. So if I make my substitution, this is really the integral of du over u. Or 1 over u times du. In either case, I know what this integral looks like. This is natural log of absolute value of u plus c, which is equal to, well, what was u? Well, look at that. U is natural log of x. So I will have natural log of absolute value of natural log of x plus c. So you end up with natural log of x plus c, which I just think is kind of fun. So that is integration by substitution. I do think this is kind of a trickier section. I would spend a lot of time practicing these problems because this is the only integration rule that we're really going to look at. We're not talking about a product rule or a quotient rule or anything like that. This is the one other integration rule besides the basic ones that we found earlier in the last section. Integration by substitution is the only major integration rule that you have to know. So this is definitely one that you should be looking at and practicing in your homework.